Okay, so 5.2, we're going to find least common multiples. We're going to add and subtract rational numbers. This lesson is pretty easy. When you're looking for the least common multiple of 24 and 50, the first thing you want to do is kind of break these into what are the prime factors of these numbers. So we're going to look at 24. And a prime number is something that only that number in itself goes into it. So like 2 is prime because 1 and 2 go into it, but nothing else. 5 is prime because only 1 and 5 go into it. 10 is not prime because 1 goes into it and 10 goes into it, but also 2 and 5, right? So when I look at 24, I always start with 2 if I can and say, will 2 go into 24? And yes, it will 12 times. And then I keep going with 2 until I can't anymore. 2 will go into 12 6 times. And 2 will go into 6 3 times. So 24 ends up being 2 times 2 times 2 times 3. Then we look at 50. Okay, I always start with 2 if I can. If I can't use 2, then I go to 3, the next prime number. But 2 will go into 50 25 times. 2 will not go into 25. 3 will not go into 25. So the next prime number that I could try is 5. And 5 goes into 25 5 times. Now I stopped on both of these. I stopped here at 3 because 3 is prime. If it wasn't prime, I would have to keep dividing out. I stopped here because 5 was prime. If it wasn't prime, I would have to keep dividing out. So what I know now is that 24 is equal to 2 times 2 times 2 times 3. I'm getting those numbers from right here. 50 is 2 times 5 times 5. Okay, the least common multiple. It's the opposite of what you think. You want to list them the most amount of times they appear in either group. So when you think least, you really want to list them the most amount of times they appear in either group. And here's what I'm talking about. So I'm looking at the 2's right here. I see 3 2's here and 1 in this group. So we want to list the 3 because 3 is more than 1. So we want to list all 3 of the 2's. You have to list it in the most amount of times it appears in either group. Okay, then the other number I see up here with 24 is 3. There's not a 3 listed down here in the 50's. And so I have to list it the most amount of times it appears in either group. So if it appears up here, I have to list it even if it's not in this group. So I have at least 1 3. Okay, the other number I see is 5. And I've got 2 5's here. I don't have any in this top with the 24. And so I want to list both of the 5's because it has to be the most amount of times it appears in any group. But when you multiply those things out, 2 times 3 times 5 times 5, getting 600, which is a really big number. So 8 times 3 times 5 times 5, 600. So what that means is if I were to, least common multiple is the smallest number that both 24 and 50 will go into. And it ends up being 600, which is pretty big. So we look at 12. What's the least common multiple of 12 and 30? So always start with 2 if you can. If you cannot start with 2, go to the next prime number, which is 3. But 2 will go into 12 6 times. 6 is not prime, so I keep going. 2 will go into 6 3 times. And 3 is prime, so I can stop there. I'm going to come over to 30. 2 will go into 30 15 times. 2 will not go into 15, but I know 15 is not prime, so I've got to keep going. 3 will go 5 times. 5 is prime, so I can stop. So what we have is that 12 is equal to 2 times 2 times 3, and 30 is equal to 2 times 3 times times 5. When we do our least common multiple, we have to list it the most amount of times it's in either group. So if I've got 2 2s and 1 2 that I'm comparing, I would list 2 of them. Both groups only have 1 3, so that's good. I can just list 1 3. The 30 has a 5. It doesn't matter if the 12 doesn't have a 5. I still have to list it. Okay, so 2 times 2 times 3 times 5 is 60. And what this means is that 60 is the smallest number that we could find that both 12 and 30 will go into. That's the least common multiple. Okay, now we're adding some letters. Yes.
So why would you not put the extra, the 32 in there, like from 30?
Well, that's a good question. So the question was, why would we not put 3 2s? Because we're looking for the least common multiple. We only have to put it the amount of times that, let me think of a good way to explain this. If we look at a smaller number, maybe that might help. So let's say, let's compare 8 and 6. Okay, so 8, 2 will go into 8 4 times. 2 will go into 4 2 times. So 8 would end up being, right, 2 times 2 times 2. 6 is 2 times 3, and we're done with that one. So 6 is 2 times 3. So we're trying to find the smallest number that both 8 and 6 will go into. Well, if I put all 4 of those 2s, it's not going to be the smallest number. It's going to end up being a bigger number than we need. In fact, it might even throw us over the edge because, so I need to put at least 3 of them. Let's just compare the 2 numbers. We put 3, and then we've got to put the 3 from this. That's going to be 8 times 3, which is 24. Okay, so will 8 go into 24? Yes, it'll go 3 times. 6 will go into 24 4 times. If we had have made it the 4 of them, and we said that that's it, then we would be saying 48. 2 times 2 times 2 times 2 times 3 is 48. And yeah, it's true. 8 and 6 will both go into 48, but that's not the least common multiple. That is a common multiple, but it's just not the least common multiple. Does that make sense? So if you list the extra one, it's going to make it be a multiple, but not the least. So if we want the least one, we only need to list it the most amount of times it's in either group when we compare.
So how do you do that on every single one? If there's like, do you just ignore the number that's on the bottom, like on the second? If there's already that number in the first one, do you do that every time?
So on every one of them, it doesn't matter if it's on the top or the bottom, I'm comparing the list. So I'm going, okay, I'm looking at every single number that I have. So on this one, I've got 2. So I started with 2s. So this one had 2 2s and this one had 1 2. And I said, of those, which one's the most amount of 2s? And it just happened to be that it was on the top. Okay. And then this one I looked at, and then you have to list every single number that's up here. So then I compared the 3s. Well, both of them just have 1 3. So the most amount of 3s I have in either group is just 1.
So if you had like 4 of the 2s like on the top, and you only have 1 of the 2s on the bottom, you would just do the 4 2s that are on the top. Yes, because that would be
the most amount of times it's in either group. You're comparing the 2. Yeah, that's a good question. Okay, so I'll mark this out because it's not the least common multiple. So on this one, we've got letters and numbers, so we're turning it up a little bit. So going to look at let's look at the numbers first because we kind of know how to deal with that. So we've got our 12 and our 18. So 2 will go into 12 6 times. 2 will go into 6 3 times. 3 is prime, so we can stop there. 2 will go into 18 9 times. 2 won't go into 9, but 3 will. So I move up to my next prime number, and then 3 is prime, so I can stop there. So if I'm looking at 12, which we know is 2 times 2 times 3, and 18, which is 2 times 3 times 3, on the number part of this, okay, I'm looking at my 2's. I've got 2 2's and 1 2. So the 2 would win, right? I've got, if this is listed more, so we would list both of those 2's. Then we want to look at the 3's. Well, this 12 has 1 3, but the 18 has 2 3's. So I'm going to have to list both of those 3's because that's the one that has more of them in it, okay? So it's the same thing with the letters. The letters are just factored out for you already, so the variables. So if I compare my a squared with my a to the 5th, well, which one's the most among those two? The a to the 5th would be bigger, right? So that's the one you want to put. If I've got a b to the 4th and a b squared, then I want to put the bigger one, which is b to the 4th. So my final answer, I would need to multiply this stuff out. So 2 times 2 times 3 times 3 is 36. A to the 5th, b to the 4th. Okay, so on this one, we're looking at 9. Focus on that first. And the other one is 5. We just look at the numbers. 9, 2 won't go into it, so I would go to my next prime number, which is 3. So 9 is just 3 times 3. 5 is already prime. So I'm comparing 3 times 3 to 5, which is just 5. There's nothing I can do with that. So when I'm listing my least common multiple, the most amount of 3's I have in either one of these lists is going to be 2 3's. The most amount of 5's I have in either list is just 1. So it ends up being all of that stuff. Okay, and then I'm going to look at my variables. I've got an x squared here and just an x to the first power here. So the x squared would win. I've got a regular old y to the first and another y to the first. So it would just be y to the first. I've got a z in this one. This one doesn't have a z, but it doesn't matter. I have to list it if it's there. Because you list it the most amount of times it is in either list. You're comparing, right? So that's going to give me 3 times 3 times 5, 45, x squared y z. Okay, questions about that? Okay, right now? Okay. We can, if you think of something in a minute, that's fine. These are pretty easy because when we're adding these, we need a common denominator, and these problems already have this common denominator. When you get to college algebra, they probably will not, but for right now, we're dealing with things that have a common denominator. So when we add, just like when you say 1/2 plus 2 halves, if the number on the bottom is the same, you get to keep it and you just add the top. So because our number on the bottom is the same, we get to keep that and let it be an x. And on the top, we're actually going to add all the way across. So 9 plus 3x plus 2. We want to reduce if we can. So we would go, is there anything that's alike that I can add? Like the 9 and the 2 can go together. 9 plus 2 is just 11 plus 3x. Okay. So we could leave it like that. They might want you to cancel out this x. Another option would be if we're fixing to talk about dividing in a minute. I think in this section, they let you leave it. So all I'm doing is separating this out. So 11 over x plus 3x over x. Well, there's nothing I can do to this, but on this one, these x's right here would divide out, cancel out, and I would end up with 11 over x plus 3. I kind of think in this section they let you leave it like that, but this would be completely simplified. Okay, on the bottom we've got a common denominator. On the top we're going to say 5 plus 2a plus 4. The 5 and the 4 can go together. So that would be 9 plus 2a over a. If I wanted to simplify it, then I could split it back up and say 9 over a plus 2a over a. I'm just dividing my fractions up, right? These two things. Well, 9 over a, I can't do anything with that. It's just 9 over a. But these a's right here would cancel out, and I would just get plus 2. And this is supposed to be an a, and that's a 9. Kind of think they'll let you leave your answer like this. But I just want to make sure you know that this is simplified.
Will we be kind of wrong if we simplify it and it's not asking, or if it's like?
The honest truth is I'll have to look at the first homework problem to tell you, because I don't know. It just depends on their notation. I think that they would count either one, but I'm not sure. So I have to look. Okay, so once again, we have common denominators here. So these x plus y and x plus y, we get to leave that alone. On the top, we have x minus 2y plus x plus 9y. So we want to combine like terms. Looks like I've got an x and an x. So these two things should be able to go together. So one x and another x, that's going to be 2 x's. Also, the negative 2y and the 9y could go together. So negative 2 plus 9 is going to give me plus 7y. And that's going to be x plus y on the bottom. I can't separate these out. I could, but it's not going to help me simplify anything. I can do that for you just to show. I wouldn't write this down. But if I simplified this out, because this whole thing is in the denominator, up here we only had like one letter in the denominator. So it helped me cancel something out. But if I split this one up, it would look like this. And nothing's going to be able to cancel out with that. So I would not do that. That's making it worse. This is simpler on these problems. So if there's one letter on the bottom, a lot of times you're going to be able to simplify. But if there's not, you probably will not be able to. We have got x squared minus y squared plus x squared minus y squared. So we know on the bottom is going to be x squared minus y squared. On the top, we're going to have everything else. Okay. I do not see anything that can go with the x squared, so I'm going to leave that alone. These two terms, the negative 5xy and the positive 2xy, they do have the same letters raised to the same powers. So negative 5 plus 2 would give me negative 3xy. I can combine those. Minus y squared. There's no other y squares that are going to go with that. This is not going to cancel out, so that we're done with that. Okay. Subtraction is a little bit more difficult, but we're still looking for a common denominator, and this one has a common denominator. But what you have to keep in mind when you're subtracting is that subtraction changes things. It makes everything be the opposite. And when you're subtracting, you don't want that minus to just go with the 4. You want the minus to also go with the negative 9a, right? When we're adding doesn't change the number behind it. So it doesn't, we can just write it straight across. When we're subtracting, it makes everything be the opposite of what it is. So when you're subtracting, you probably need to start out by saying, oh, I want to subtract this whole thing. So I put it in parentheses saying, look, I need to subtract this whole thing, not just the 4. I need to subtract the negative 9a too. So that's going to give me 7. But then we want the opposite of 4, which is negative 4. We want the opposite of negative 9a, which is going to turn into positive 9a, still over 4 plus a on the bottom. Right? Whatever's inside you're subtracting has to become opposite. Then you can combine like terms and say 7 minus 4 is 3 plus 9a over 4 plus a. There's nothing else I can do with that. On the box, same thing here. We've got our common denominator. We want to do 9y minus 2, but it's minus this whole thing, this y plus 2. It's subtracting that whole thing. So 9y minus 2 minus, it was a positive y, so it becomes minus y. It's a positive 2, so it's going to become negative 2 or minus 2. Okay, so combining like terms here, I've got 9y minus, this would be a 1y if there's no number here. So 9 minus 1y is 8y. And then I've got negative 2 minus 2, which is negative 4. Y squared minus 10 would go on the bottom. Okay, and so that is 8.2.